Hello, student. Your chemistry tutor is here again. I want you to like my video. I want you to subscribe to my YouTube channel, and I also want you to share this video to other students, secondary school students, higher institution students. You share to them so that they have a detailed knowledge of this topic. Well, this is a question I have seen in most past question, and I think I should give an answer to it. Most times, it has brought confusion to many students, and many students they have defined one for the other. Now, the question is explain activity, specificity, and selectivity of a catalyst. So I'll be taking them one after the other. Let me talk about activity of a catalyst. By activity of a catalyst, what do we mean? Activity of a catalyst mean number one, activity. By activity of a catalyst, we mean the ability of a catalyst to increase the rate of reaction. So we have many catalysts that can increase the rate of chemical reaction, especially the positive catalyst. So the ability they have to increase the rate of chemical reaction define activity of a catalyst. For example, hydrogen gas and oxygen gas actually cannot combine normally, but in the presence of platinum catalyst, the combination of hydrogen and oxygen gas forms water, as you have in this reaction. Hydrogen plus oxygen gas will give you water. Under normal circumstances, if you do not introduce catalyst to this reaction may not occur, or if it occur, it will take a very long time. And what makes the reaction to be fast and increase this speed is the introduction of a catalyst called platinum. Okay, to balance the reaction, put two here, you put two here. Then the reaction is balanced. Now, I have another example in some industrial processes where catalysts are used to increase the reaction process. Like I have one example of the ammonia synthesis in the synthesis of ammonia. Okay, I'm not going to be giving this reaction because the detail of this reaction is already explained in my first video. The name of the video is Catalysis 1. So when you watch it, you get detailed explanation about that. Okay, so in the synthesis of ammonia, the catalyst that is used is actually finely divided iron. Okay, without the use of this catalyst, this reaction will be extremely slow. So the addition of this catalyst to this reaction makes it to increase fast. So that explains the activity of what the catalyst. Another one is the of manufacture or industrial preparation of sulfuric acid. The catalyst used, let me talk about processes and catalyst. I think this will be better. Processes, then catalyst. So the catalyst used here is V2O5 or platinum, finely divided platinum in the industrial preparation of sulfuric acid. V2O5 is called vanadium pentoxide. It is an oxide of a transition element. The name of the transition element is vanadium. Okay, so when you are asked, I also saw in one of the past questions, that one of the oxide of platinum, one of the oxide of transition metal used in the manufacture of sulfuric acid is what? Many students get confused. The answer in that case is not platinum. Okay, the answer is vanadium pentoxide, which is V2O5. So another example to explain activity of a catalyst is the cracking of petrol. Cracking of petrol. The catalyst used in the cracking of petrol is zeolite. Okay, so the presence of the zeolite as a catalyst helped in fastening, increasing, speeding up the rate of this chemical reaction. So in summary, if this catalyst is not present, if this catalyst is not present, if this catalyst is not present, and this is not present, and this is not present, the reaction will be very sluggish. And that sluggishness will make the reaction to stay for a long time, that little or no product may even be formed. So the introduction of the catalyst increases the reaction. That increases the speed of the reaction, so that the reaction takes place at a shorter time. That means it defines the activity of the catalyst. The other one, I hope you understand what I mean by activity now. The other one is called specificity. It is just an English word, specific. Catalyst is specific. Please understand, activity, specificity, and selectivity, they are actually important features of a solid catalyst. They are important features of catalyst. So when we talk about specificity, we are talking about catalyst being specific in reaction. Okay, so I'm going to define it this way, that the ability, I need to write this for those who want to write, the ability of a catalyst to channel same reactants, the ability of a catalyst to catalyze. I was almost explaining selectivity. So there's the ability of a catalyst to catalyze a particular one type of reactant to get a particular product. The ability of a catalyst to catalyze only one type of reaction, to catalyze only one type of reaction, okay, to get a particular product. I hope you can see my handwriting. I think it is visible to you. Okay, so the ability of a catalyst to catalyze only one type of reaction to get a particular product. This actually means you want to get a particular product from a reactant. So you use a particular catalyst to catalyze that reaction. That explains specificity. The third one is the selectivity of a catalyst. I want you to listen. Selectivity of a catalyst. This I'm going to give a broad explanation. The selectivity of a catalyst. Okay, what do we mean by selectivity of a catalyst? It is the ability of a catalyst, the ability of a catalyst, okay, to to channel same reactant to give different products. Please note this: to channel same reactants to give different products. In chemistry, it is good you use equation to explain your point, okay? For example, you have ethanol and you catalyze this ethanol with boron phosphate. Because you use a catalyst, boron phosphate, to catalyze this reaction of ethanol, the product you have is ethylene and diethyl ether. Those are the products you are going to have. The same reactant, if you catalyze it with molybdenum carbide versus carbon, that means mixture of molybdenum carbide and carbon, with this formula molybdenum carbide and carbon, okay, you are going to obtain hydrogen plus acetaldehyde, okay. The same reactant, if you catalyze this reactant using Na2Cr2O7, which is sodium dichromate, okay, sodium heptaoxo dichromate 5. So if you are going to use this, you are going to obtain ethanol, okay. So you see that you have different products from the same reactant using different catalysts. This explains the selectivity of a catalyst, the ability of a catalyst to channel same reactants to give different product. I think this is well understood. I call this example 1. I have another example to give to you. In the reaction between carbon monoxide and hydrogen, if you catalyze this reaction with nickel catalyst, you will obtain methane and water, okay. This reaction, you balance the reaction. I think it is balanced this way. Yes, it's balanced. So if you use the same reactant and you change the catalyst to mixture of zinc oxide and chromium oxide, you are going to have methanol. Methanol will be the product obtained. If you use the same reactant to obtain methanol, this is methanol as in like this, an aldehyde. This is methanol as in alcohol, okay. So if you catalyze this reaction using copper metal, you are going to have methanol, okay. So this reaction is not balanced, okay. I think it is balanced this way. So you can see that these different products have formed from the same reactant, depending on the type of catalyst you are using. Okay, this explains the selectivity of a catalyst. You can see it. So these are good examples that explain the selectivity of a catalyst. So I think you understand this. Okay. But meanwhile, you see that you want to obtain a very particular type of product, then catalyst become specific. Okay. So in a summary, specificity and selectivity. Specificity describes finding the exact product using a particular catalyst. Selectivity describes finding several products from same reactant using different catalysts. I come again. Specificity describes finding the exact product using a particular catalyst. Selectivity describes finding several products from same reactant using different catalysts. I am very sure, my fellow student, I am very, very quite sure here that you understand what this topic is all about from this video. So I want you to show an appreciation by just sharing it with somebody. Do not be stingy. Share the video with somebody and subscribe to my YouTube channel so that whenever I upload new video, you will receive notification. Please, I beg you, like my video, subscribe to it, and share to others. If you have any question, you can drop it in the comment section. And also, if you think you disagree with some of the knowledge I'm sharing here from this video, you are free to make your point in the comment section. Okay? And I am going to treat them accordingly. Thank you and God bless you.